This video contains traces of severe stupidity and scenes of graphic ownage. Viewer discretion is advised. First looked at the stars, really looked at the stars, was on a trip to South Africa. Now, I remember how clear the sky was, and when I looked up I could see a billion points of light, all perfectly still, and yet seeming to dance at the same time, like candles on a chandelier hanging from a vast obsidian ceiling. As the whole galaxy rushed into my eyes, I felt a deep connection to the stars. It shook my soul, and I knew I would never forget that moment. One star I'm particularly fond of became a subject I studied with great interest at university, and perhaps I was being naive, but I thought everyone had at least some understanding of our knowledge of its formation, composition, and interaction with the Earth-Moon system. Then I discovered creationists.
The moon fits over the sun so perfectly that it makes it possible to observe the surface of the sun. Otherwise, this would be impossible. If the moon was too big or too small, it would be impossible. Because of our vantage point from the Earth, the moon fits perfectly over the sun, the chances of which are 1 in a trillion.
Observe that I have nothing up my sleeve, no moons or eclipses, and then prepare to worship me as I show you the impossible, the surface of the sun. Okay, so it wasn't magic. It's science. Thanks to two sadly lesser known, but no less extraordinary feats of spacecraft engineering, we as a species are enabled round-the-clock access to the intricate behaviour of our star, monitoring its weather and even probing its mysterious thermonuclear engine at a level beyond the wildest dreams of ancient sun-worshipping cultures. Solar eclipses are a beautiful natural phenomenon, but they are outdated in the world of solar science. The size of the moon is more or less constant, but it does recede from the Earth at a rate of about 3.8 centimeters per year. This is because it is tidally locked with the planet and encounters tidal friction. This is also slowing the Earth's rotation, though it will take around 15 billion years to come to a complete stop, so don't hang around. It is possible to calculate how long it will be before total solar eclipses can no longer happen. By my maths, it's a little over 530 million years. As for Sean's 1 in 1 trillion chance statement, well, I can only imagine which creationist tool dreamt up that number before he parroted it, but rest assured the chances are better. The chance of the moon being the right size are 1 in 1, because it's our moon, and it's as big as it is and effectively always has been. Furthermore, with 500 million years left to observe this phenomenon, I'd say we evolved in good time. Who knows, future generations may even see the development of other conscious species capable of studying solar eclipses. Meet Jason Lissel, a speaker for Answers in Genesis who dubs himself a creation astrophysicist. Jason has relatively impressive credentials when compared to the average creationist, and has authored several secular papers. He and I have something in common. We're both fascinated with solar astrophysics. He completed a PhD on the dynamics of solar supergranulation and its interaction with magnetism using data from the SOHO spacecraft, which in my view must have been very interesting. Unfortunately, even when a man with a CV like his says,
"Now the Bible's not an astronomy textbook, but when it touches upon astronomy, it's right,"
you just know he's full of crap.
Also, the angular momentum of the sun ought to be spinning like mad if it really collapsed from an enormous cloud, because you can imagine that. I mean, a skater pulls her arms in just a little bit, she speeds up a lot, right? Well, imagine a cloud, light years across, coming down to this tiny little, think of it like a pin, the head of a pin. It would be spinning incredibly quick, and a very few stars do spin quick, but most stars don't. They're closer to the sun. The sun takes about 25 days to rotate.
Actually, the sun undergoes what we call differential rotation. This is because its surface is not rigid, but fluid. The result of this is that at the equator, the rotational period of the sun lasts about 25 Earth days, whereas near the poles it lasts about 36 Earth days. How do we know this? By observing sunspots. These huge magnetic storms act to reduce convection of heat to the surface, resulting in a lower temperature. We can image them continuously and time their passage for any given amount of the sun's circumference. Jason's analogy of an ice skater pulling in her arms is spot on. When a nebulous cloud collapses to form a star, any initial angular momentum that cloud possesses will indeed result in relatively fast rotation of the star system. So what's the problem? Well, claims like this may go over the heads of most people, but to me it's a gross oversimplification combined with a good old red herring, otherwise known as a big fat lie. When it comes to science, you just can't skip over the details like that. The sun is and has always been slowing down. The process of stellar spin down is not fully understood, but what we do know explains a lot. To begin with, not all of the angular momentum of the star system belongs to the sun, but is distributed to the entire system, including the enormous protoplanetary solar accretion disk from which the planets formed over billions of years. Rather than orbit statically, they rotate because their individual formation was, in a way, similar to that of the sun, a gradual collapse of a cloud of material. Because they acted to conserve this angular momentum, it was preferable for them to rotate the same way as the sun, and most of them do. Venus rotates the wrong way, albeit very slowly, and Saturn and Uranus are both awkwardly tilted. Exactly why is simply not known to anyone, but there are good estimates. Yet I have never heard a creationist suggest a decent hypothesis, even though many of them consider it to be some proof of creation. So, we know that the sun does not possess all of the system's angular momentum, but we can go further than that. The sun contains about 99% of the mass of the solar system, yet it has, get this, less than 0.5% of the angular momentum. So just where has it all gone? Remember, it cannot disappear. For the answer, we need to look at my favourite planet, Jupiter. It is a very big planet, volumetrically about 1,000 times larger than the Earth. Just bearing that in mind, I want you to appreciate that when I tell you a day on Jupiter lasts about 10 hours, I mean it has a lot of angular momentum. In actuality, it has about 99% of that of the whole solar system. Exactly why is another curious mystery, but planetary formation theories are young and the inability to explain something is not substantial enough to prove the creation conspiracy. So what now? Why is the sun slowing down? Well, the sun loses over 4 million metric tons of mass every second, literally as sunshine. Consequently, it is losing internal energy and thus kinetic energy. Turbulence at the surface also induces frictional heating, which is another source for energy loss. I know what you might be thinking, that this reduction in angular velocity reduces the angular momentum of the sun. Well, partially. See, the orbits of the planets are receding very slowly, but more importantly, the ice skater analogy does not give us the whole picture, and I think Jason knows it. The equations that the high school physicists used to calculate angular momentum were developed as part of rigid body kinetics. As I stated earlier, the sun is not a rigid body, but is actually a fluid, and its angular momentum is complex. As it spins down, apparently losing angular momentum, we observe eddy currents on the surface, and presumably they occur under the surface as well. These currents possess angular momentum donated from the system. In short, it is conserved. Here ends episode 2 of Crap Debunked. Thank you to everyone who subscribed and commented, and a big thanks to Don Exodus too for the shout out. This is Andromeda's Wake, wishing you clear skies and good debunking.